All right, today we're going to be talking about adding rational expressions. And I'm going to apologize, this is going to be a little bit of a longer video than I usually do. So when we're adding rational expressions, there's one thing that we always have to remember, that in order to add, and think about just how it works with any other fraction, you must have a common denominator to add. So that means that our first step is going to be converting to equivalent fractions with a common denominator. And then when we add, remember, we're going to simply add or subtract the numerators only. And of course, at the end, we're going to reduce the results. I can spell too. So we're going to reduce our results at the very end. If you don't add things with a common denominator, you will end up with something wrong. If you add both numerators and denominators, you'll end up with something wrong. If you end up with a right answer, you made at least 2 mistakes and you got lucky. And to my mind, that doesn't mean you're right. That means, well, you're lucky. All right, let's start out, and I'm going to just show you a little bit what this would look like if we already have a common denominator. So say we've got something like x over x squared minus 1, and then plus 1 over x squared minus 1. So I already have a common denominator here. Here's our first example. So here, all we're doing is adding together our numerator. This is going to be x plus 1. Oh, x plus 1 over our x squared minus 1. So we just add our numerators. And now I get to reduce this result. What I've got here in my denominator is a difference of squares. So this is going to be my x plus 1 over x minus 1 and x plus 1, which means I get to reduce this. So I've got 1 over x minus 1, and we're done. Now, we don't always have, now this was really convenient, having a common denominator already. But we don't always get that straight off the bat. So say we have something maybe a little bit more, something that might be a little simple, but let's do this one. So I've got 1 over x plus 2 over x squared, and I'll do minus 3 over x cubed. Now, one thing that I'm going to point out is that a common denominator it has all of the factors that are present in all of my denominators, and it's going to have the highest power of the common factors. So in this example, I've got x squared, and x cubed. So x is clearly a common factor, and I have to choose my highest power. So it's going to be x cubed. So in order to convert this, I'm going to have to say, oh, I'll take this 1 over x, and I'm going to multiply this one by x squared over x squared. Now, notice I'm just multiplying by a well-chosen 1. X squared over x squared is equal to 1. Well, Now with my 2 over x squared, I'll multiply that one by, oh, I only need to have this be x cubed, so I'm just going to multiply this one by x over x. And I already have that x to the third power for this last term, so this is just going to be 3 over x cubed. I don't need to do anything to that one. Now when I multiply, I'll have x squared over my x cubed plus my 2x over my x cubed, that's a 3 there, and then minus 3 over my x cubed. At this point, I can add together my numerators, and I'm not doing anything to my denominators. So this is just going to be x squared plus 2x minus 3 over my x cubed. Now, it wouldn't hurt to factor my numerator, but it's not necessary. So I can be done right here. One other very important aspect when we're talking about finding a common denominator is, like I say, it encompasses all factors. So let's show you what that is going to look like. Let's say I've got 3 over x squared minus 9. Now let's subtract from that 2 over x squared minus 2x minus 3. So our first step is going to be, we're going to fully factor our denominators. I'm not going to go through the process of factoring here. I'm just going to show you what the result is. So I hope you, if you are trying to figure out what happened in this next step, I would encourage you to pause the video and work that one out. Work these out. So this is difference of squares. So this is going to be x minus 3 times x plus 3. I'm going to leave myself a space here because I know I'm going to be multiplying this here very soon. At 2 over x minus 3 and x plus 1. So we fully factor our denominators, and the next thing that we're going to do is remember that our common denominator contains all of the factors. So my denominator already has, both of my denominators already have a factor of x minus 3. It looks like what I'm missing over here on this term here on my left is a factor of x plus 1. So I'm going to multiply this one by x plus 1 over x plus 1. I'm going to multiply this one, since now this has both of these factors here, and it looks like this one on the right is only missing a factor of x plus 3. I'm going to multiply this one by x plus 3. Now I can go ahead and I have to multiply my numerators. You must multiply your numerators before you add. So this is going to be 3x plus 3. And this is my x plus 1, x minus 3, x plus 3. This is going to be minus. I'm going to go ahead and distribute this. So this is going to be 2x plus 6. And I've got I'll keep this in this order. So I'll have x plus 1, x minus 3, x plus 3. One thing that I also want to point out here is this is subtraction. I'm subtracting this or I'm subtracting this 2x plus 6 from this. So when I subtract, I want you to think of this as, so when you see what's happening here in my numerator, this is 3x plus 3 minus 2x plus 6. This is going to end up being, 3x plus 3 minus 2x minus 6. This minus is going to get distributed to both of these terms. So when I add these together, 3x minus 2x is just x. 3 minus 6 is going to be minus 3. Over x plus 1, x minus 3, and x plus 3. And conveniently, I've got something that's going to reduce. So now I've got 1 over x plus 1 and x plus 3. And it's okay, and I would even say recommended, that you always leave that denominator factored. It's going to be helpful for you later. All right. So how about we do one more example to bring this home for us here. And let's do this one. This one is a little bit, this one is subtle, but I like it. I've got 3x plus 1 over 2x minus 6. And I'm going to subtract from this x plus 2 over our x minus 3. So our first thing that we need to do is we need to fully factor our denominators. Well, I can't factor this one here on the right, so this is just going to stay x plus 2 over x minus 3. But I can factor out a greatest common factor here on the left. So this is 3x minus 1. And I've got, if I factor 2 out, I've got 2 times x minus 3. And now I can see that I've got a common factor of x minus 3. So what is my missing factor? Well, I'm only missing a factor of 2 on this particular one here on the right. So I'm going to multiply this by 2 over 2. So when I multiply by 2 over 2, I'm still, 2 divided by 2 is just 1. All I'm doing is changing the form of this without actually changing the value. So I've got my 3x minus 1 over this 2 times x minus 3. That's going to be minus 2x plus 4 here. 2 times my x minus 3. I'll go ahead and take an extra step. We were running out of space before, so I didn't want to take that extra space. So I'll say 3x minus 1 minus this 2x plus 4 over our 2 times x minus 3. So that's, so thinking about this, we've got our 3x minus 1 minus 2x minus 4 over our 2 times x minus 3. And it looks like I've got 3x minus 2x is going to be just x. 1 minus 4 is going to be a minus 5 all over our 2x minus 3. Oh, you know what? I made a mistake. I made a mistake up here. This is a plus 1. So that changes things. I'm about to say, I thought I had a slightly different answer in my notes. So when I look at that, this is going to be plus 1. Let's see here. 1 plus 4 is actually a 3. There we go. That makes more sense. My apologies for people who've been screaming at me like, where did my sign go? Here it went. We found it. X plus 3 over x minus 3 over x minus 3 is 1. So this is going to be 1/2. This entire thing comes down to 1/2. Alrighty, that's all I've got for right now, and I will see you in the next video.